Hello. Today we are going to be doing lesson 17 from Unit 3, and we are on page 171. So go ahead and turn to page 171. Pause if you need a minute. All right, so today we're going to be talking about using the graphing technology. We're going to talk about using Desmos to do these inequalities, two variable inequalities. And when given inequalities, graphs and describe the represent the constraints in a situation, I can connect the different representations and interpret them in terms of the situation. So we're going to be looking at the inequalities, the graphs, and the descriptions and seeing how they all connect together. All right, so we're not going to do the bridge, so go ahead and turn the page and go to your warm up on the top of page 172. And go ahead and open up Desmos. It's going to be kind of, you want to just follow along at first or flip back and forth. It's good practice. But when you first go to your Desmos, you want the graphing calculator. And for this activity, we're just going to leave it with the Desmos calculator here. Not going to change anything, but we're going to talk about that later. So I'm going to be flipping back and forth between Desmos and your book. So first one, you're just going to do y is greater than x. So in Desmos, just type y. You can use greater than the shift period greater than x. You do it that way. Also in Desmos, there's a little keyboard down here. If you pull that keyboard up, there's a greater than right there. So y is greater than x. You can do it that way. But you can see when you graph y is greater than x, you're going to end up with this. And it's important that if it's greater than or less than, if it doesn't have the or equal to, this is a dotted line because every point on that line represents where y is equal to x. So we don't want to include those points. We only want the ones that are greater where the y is greater than x. And that's this whole shaded pink region. If you ever want to change your graph color on Desmos, come up here to this little wheel. It's a little gear for settings. Click on the color, change to whichever color you like, and you can do it that way. So if you just click on it here, it just turns it on and off. So use that wheel and you can do any color you want, same color, stuff like that. So that's our graph. So make sure when we do that, we're doing a dotted or a dashed line, and then the greater than area is shaded up here. You don't have to do solid shading, just get an idea of that's the region we're talking about. So every point up here, say this, let's say that's 3, 7, over 3 up 7, let's say that was the point, you'd see that the y is going to be greater than the x. So every point in this region, the y will be greater than the x. So what's different for number 2? So when you go to Desmos, to type greater than or equal to, you can use that keyboard feature or just do the greater than symbol and then the equal right up there at the top of the keyboard. If you do it right after, it will do greater than or equal to. So shift and that greater than, and then hit equal to x. And the only difference is now every point on this line where y is equal to x is included because it's or equal to. So that's a solid line. So when you have that or equal to, you're going to see that solid line on your graphs. So now this is a solid line and still greater than is shaded up here. So it's every point in the shaded region and on the line make that a true statement. Here it's just every point in the shaded region because the line's not included. That's why it's dotted. All right, so let's look at the next two. Y is less than -8. So go over, I'm gonna get rid of that one. Y less than -8. And so as we move around, we can see down here, there's -8, y is less than, so it's going to be that whole, again, not equal to, but less than. If we go back, y is less than -8. We're just going to do, that's below that, where this point is -8. Since this graph doesn't go, we're not going to count this as 1, 2, 3 because it'd be way down here. So just assume, but it'd be shaded below that. Everything below -8 doesn't matter what the x value is. X could be positive, negative, x could be 0. It's just y has to be less than -8. All right, -x plus 8 is less than or equal to y. So -x plus 8 got to be less than, so shift less than and hit the equal sign right after it, y. So there's our region. Again, less than or equal to, it's going to be a solid line. You can see the intercepts are at 8 and 8 on that way. So if we're going to graph, it's like it's like this, right? This is 8. That's 8. And our shading was above the line. So our shading is up here. So every point up there and on the line would make that a true statement. All right. So if you see what I'm doing, or if you've done them yourself, pause if you haven't done those yet. Try to graph these two. See, you're going to have to search around. All right, if you've unpaused, less 2y is less than, I know that's going to be a dotted line, 10x minus 200. That's got a y-intercept of -200, so I know it's, there it is. I can zoom out that little negative over there. It's going through 200. It's a very steep line, but -200 is the y-intercept. Up here, the x is 20, and it's a dotted line. So if we graph that, we know it's going through -200 and 20. It's a dotted line and shaded to the lower side of the dotted line. And then the last one, again, I know that's going to be a dotted line. So if we graph that, 2x plus 3y has got to be greater than 60. We can see from that that the intercepts are at 20 and 30, dotted line shaded above. So the intercepts will be at 20, 30, dotted line, shaded above it. So that's Desmos calculator. Put them in, pretty simple. Make sure you get the shading. So next, we're going to look at this activity one. It says here are 3 situations: bank accounts, concert tickets, advertising packages. There are 2 questions about each situation. For each question that you work on, write the inequality that describes the constraints, specify what the variables represent, use Desmos, sketch the solution, name one solution to the inequality, and explain what it represents in that situation, and then answer the question about the situation. So there are 3 of these, like it says on the next page, 173 174, and 175. Try those three with Desmos, pause, and come back and see. All right, so hopefully you've tried these. So a customer opens a checking and savings account at a bank. They will deposit a maximum of $600, some in the checking account and some in the savings account. They might not deposit all of it and instead keep some of the money as cash. So if the customer deposits, so there's the question. So here's the situation first. So let's look at what's going on. We have two types. So I'm going to say X equals the money in a checking account, and Y is going to be the money in the savings. And it says that this customer is going to deposit some money into checking, some in savings, with a maximum of 600, but that they might not do it all. So this could equal out to be less than or equal to 600. They can't go over 600. So if that's our inequality, we can go over to Desmos and look at X plus Y. It's got to be less than or equal to 600. And with this type of situation, you can see from the graph, it's just a first quadrant graph. That's all that's important in this situation, right? So we don't care about these negative numbers because we're not going to do a negative amount in two. We just care about this first quadrant where everything's positive. And our intercepts are at 600 for both of them. So we know to sketch 1, 2, if I count by 50s, 50, 100, 150, 200, 250, 300, 354, 455, 6 would be right at the top. So if that's 600, 1, 2, 100, 2, 3, 4, 5. Same thing here. And it's or equal to, so it's a solid line. And it's got to be less than. So we know that anywhere in this region represents that situation. If a customer deposits, so that's the inequality part. We have the information. There's our graph or our equation. There's our graph. Now we're going to look at the situation or the question. If a customer deposits 200 into checking, so remember, X is the checking. So down here, that's checking. On the side is savings. So 200, change color. So 200 would be right about here. So this line straight up represents all the deposits that are possible if the person deposited 200 in their checking account. What can you say about the amount of deposits in their savings account? I'm going to look at it on the graph also. So remember, that's the X is yours. So it says, what if X equals 200? Remember, we get that vertical line. Well, the most you could deposit up here would be 400 into savings, but you can deposit all of these less than 400 also because you don't have to do all 600. So that's your Y value. So we could say that if this is true, if you have 200 into checking, then Y would have to be less than or equal to 400 for that answer, right? It can be here at 400 or any number below. All right. Second situation, the bank requires a minimum balance of $500 or $50 in savings. So again, if this is checking, this is savings. then we know X equals money in checking. If we're going to define our variables, Y equals the money in savings. Then if a customer bank requires a minimum, so we know that the Y has to be greater than or equal to $50. And that's all it's talking about is the savings account. Doesn't say anything about checking other than doesn't matter how much money is kept in checking. So we just know that Y has to be greater than 50. So if we go, we know the Y has to be greater than or equal to 50. So it's going to be that horizontal line. 50 we said was here. So we know all deposits have to be above. Now we're just talking about the fact that it has to be $50, not the first part. We're going to put everything together later. But right now we're just looking at if you have to have 50 in savings, it has to be above that line. So now we can answer the question based on this. If a customer deposits no more money in the checking account, but is able to maintain both accounts without penalty, what can you say about the amount deposited in the savings? If the customer deposits no money in checking, so no money in checking would be here, right? 0. So this, the y-axis represents no money in checking, right? But is able to maintain both accounts without penalty, what can you say? So again, if that's the intersection at 50, we know, and it's actually the same answer, that the y has to go up above that. So y has to be greater than or equal to $50. You don't have to put any into checking. All right. On page 74, concert tickets. So there are two kinds of tickets to an outdoor, lawn tickets and seat tickets. So let's say X is the lawn tickets and Y is the seat tickets. Fewer than 400 tickets in total were sold. So don't know how many of each type, but if we add them together, we know it's less than, fewer than, not equal to, fewer than, so it's just less than 400. And if this is lawn, this is seat tickets. And we're going to do X plus Y has to be less than 400. It's going to be that dotted line with 400 as your two intercepts. So if we count by 50 again, 50, 100, 150, 200, 253, 400 would be there. 100, 2, 3, 400 here. And it's a dotted line. And we know it's got to be in this region. If you know exactly 100 lawn tickets were sold, so that's saying if X equals 100, we know lawn tickets is 100 right here, and all of this vertical line. Right? So if we know that's the exact amount, then that intersection, and we can see it on Desmos, if we know that X equals 100, then we know can't be 300 because it's on that dotted line. So this intersection is at 300, but that's on the dotted line, so we know that the number of seat tickets has to be less than 300, right? Can't equal 300 because that'd be exactly 400 tickets and we have to have less than 400. So any number less than 300 would work down to 0 because all of that would be in that shaded region. On the second part of that one, so different situation, lawn tickets cost $30. So again, will be X equals lawn tickets. Y equals the seat tickets. 30 for each lawn ticket. So 30 for each lawn and 50 for each seat ticket. And the organization wants to make at least, so at least means they want to make equal to or more than $1,400. So there's our situation. That's the inequality we're going to graph. If we come back, we know that 30x plus 50y has to be greater than or equal to make their goal $14,000, which is 466.67. So back, that's 280 and 466, so 280. So if that's 200, 250, 280, it'd be about there. The other was 1, 2, 3, 4, 54, 467, pretty much if you round. And this solid line, so they need to be in this region greater than to make at least $14,000. So if you know exactly 200 seat tickets were sold, so that's the seat tickets, the Y. So if we know that Y equals 200, what can we say about the lawn tickets? Well, there's 200, right? 200 would go this way. So we know from this point over, all falls in that shaded region. So Y would have to be greater than or equal to, and we need that point. So if we come over, do Y equals 200, you can see that we need, so if they sold 200, 133 would not be enough tickets. That would fall short. So we have to, even though this rounds to 133, you have to think about money. You have to go above 133. So the lowest number of tickets they could do is, or this should be X. Oh, sorry. Your X would have to be greater than or equal to 134 tickets. Because again, that's 133.3, but if you rounded down, it would come back into the unshaded region. You got to go above that. All right, and then last one was the advertising package. So an advertising agency offers 2 packages for a small business who need advertising services. A basic includes only design and a premium. The agency goal is to sell 60 packages. So let's let X equal the number of basic packages, and Y is going to equal the number of premium packages. And their goal is to sell at least 60. So Don't know how many of each, but we know when we add them up, at least means more than or equal to. So 60 would be the minimum. So I know in that situation, the two intercepts are 60. So this time I'm going to count by, let's do tens. 10, 20, 30, 40, 50, 60. 10, 20, 30, 40, 50, 60. So I know 60 will be the intercepts. And we can see that x plus y greater than or equal to 60. If I can zoom in. We know 60 is the intercepts, and it's shaded up here because you want it to be greater than 60. So the shading is up on this side. And then it wants to know if the agency sells exactly 45 basic packages. So that's X. So it wants to know if X equals 45. So 10, 20, 30, 40, it's about here, 45. Then the Y, oh, I did Y equals. Let's go back. There we go. So if X equals 45, so that is 10, 20, 10, 20, 30, 45, so about here is your X. So from that point, your Y would have to be greater than or equal to, and we need to know what the intersection is there. So if we say if the basic ones equal 45, then it's 15. So our Y would have to be greater than or equal to 15 packages so that you sell at least 60 of them. 15 would be the minimum, but you can sell more than that. All right, so a different situation, but the same stuff. So X equals basic packages, Y equals premium packages. This time the basic has a value of 1,000, premium package has a value of 2,500, and the agency's goal is to sell more than 60,000 worth of packages. So they're going to get $1,000 for each basic plus $2,500 for each premium, and they want more than, not equal to, they want more than 60,000, so it's got to be greater than 60,000. So new situation, they have $1,000 for a basic plus $2,500 for each premium. They want that to be more than $60,000. So again, not equal to, so this is a dotted line. So it's going to go through 24 and 60 are your intercepts. So 10, 24 goes a little bit above. 10, 20, 30, 40, 50, 60. Label those so we know what numbers those are, 24 and 60, and it's a dotted line. And anything up here, any combination of packages up here is going to meet or exceed that goal. Well, we have to exceed 60,000. So all of these numbers exceed 60,000, all of those combinations. So if we know exactly 10 premium packages were sold, so premium is the Y. So if we know Y equals 10, if I know y equals 10, that's here, that y is 10 going straight across, then I know my x has to start there, right? So x would have to be, can't be equal to, because that'd be right on that dotted line. It has to be greater than, we need that number. So over here, if we know the y equals 10, then the x needs to be 35. So x has to be greater than 35 packages to meet their over $60,000. So in other words, X could be 36 or more packages as long as you sell 10 of the premium. All right, so that should take us to the end of lesson 17. So you should see your assignment in the practice problems. So try those practice problems and have a great day.